Hello everyone again and welcome to my channel. Quite interesting because we'll be looking at the properties of enzymes, and it's kind of interesting how enzyme works mostly in the biological level and how this is really crucial for the survival of human beings and also life in general. Let's look at the first property of enzyme. One of this particular property of enzyme is that enzymes are known to have a high rate acceleration. And what does this mean? This means that if you put this particular enzyme in a particular reaction versus when you don't put an enzyme in a particular reaction, what will be the relative rate of reaction in respect to those two particular systems? First of all, we're going to look at two enzymes and we're going to compare each enzyme's conditions when first placed under non-catalytic system with a rate constant of per second, and on the other side we'll compare that with the rate of the catalytic system with a rate constant of seconds raised to the power of -1. And on the other side we're going to look at the rate enhancement. And what is the rate enhancement? Rate enhancement is the ratio between the rate constant when you include the catalyst versus that when you don't include a catalyst, to see the orders of magnitude between those two particular systems. Now, first enzyme is called carboxyl peptidase. Now, this particular enzyme is quite crucial in organic reactions, most especially electrostatic catalytic reactions in the presence of zinc. Let's just look at this particular enzyme and see what it is when it is not in a particular biological reaction system. Now, what we discovered is that if you remove it from a biological system, all we get is it gives us 10 raised to the power 9 seconds in order for we to be able to at least convert one particular molecule of our substrate into a particular product, which is really slow. It takes pretty much a lifetime for that to actually occur. It's quite unfortunate that happens. However, if you look at when you include this particular catalyst in a particular system or in the same system, what we get as our turnover process is not turnover yet, we'll talk about turnover later. What we get in this particular result is that we get 578 molecules converted in just 1 second. That is really amazing to see that orders of magnitude in there. And then if you're looking at the particular ratios between that catalyzed rate versus the rate which is uncatalyzed, what we have is a 10 raised to the power 11 orders of magnitude, which is really huge and impressive for that matter. On the other side, we're going to be looking at another particular catalyst called urease. And urease is quite fascinating because this works with nickel at some point in mostly at the catalytic site, and what that does is that it enhances other reactions mostly in the biological level. So when you don't include this particular protein in a reaction, and what we got here is that we have our rate constant to be 10 raised to the power -10 order of magnitude, which is really slow. So for every one molecule, it takes 10 raised to the power 10 seconds for we to be able to cover one molecule of our compound into our final product. Quite unfortunate, really long process. This doesn't support life. However, if we try that, including this particular protein in a particular system or catalyst in a particular system, what we got here is that we have 10 raised to the power of 4 molecules converted in 1 second, which is pretty brilliant. And as a result, if we check the rate enhancement, what we get is 14 orders of magnitude as a huge gap between the rate of our reaction when the catalyst is present versus when the catalyst is absent. Now, what do we conclude from this particular analysis over here? What we concluded that we'll be able to show that the spontaneous rate of biochemical reactions rate is mainly between, let's say, greater than 1 billion years approximately, which is really slow. And if that is happening, then I don't think life will actually exist, because if you look at life has been in existence for pretty much billion years. So it's going to be quite interesting how enzyme played a really huge role in performing various biological chemical reactions at a faster rate in order for we to get various of these interesting molecules, mostly organic molecules, that supports life. However, if you're looking at that with respect to most enzymes have a particular rate constant which is between the range of 100 to 1000 molecules per second, and that is really a huge step compared to that of our regular spontaneous rate of reaction, which is really slow in real life, pretty much around greater than 1 billion years. Now, what other thing you need to note is that the rate of acceleration by enzyme has revealed that the fastest enzyme possible is sulfatase, and it's quite impressive how this particular enzyme has the highest rate efficiency, and which is about 2 times 10 raised to the power of 26, pretty much close to Avogadro's constant, or even more than Avogadro's constant. So it's pretty much impressive to see how much this is converting molecules per second, and this shows how effective this particular enzyme and enzymes in general can be. All the same, that is about it for this particular system of high rate acceleration. And our next one will be looking at the turnover, which is another property. The turnover number really shows how much molecules are being converted in a particular system when an enzyme is present for every second. And it's quite impressive as well how we were able to actually conclude that. For example, let's say we have one molecule of catalyst, right? If you have one molecule of catalyst, or let's say for example, let's choose a particular catalyst called catalase, what we realize is that this one molecule of catalyst can actually convert 4 times 10 raised to the power 7 molecules of H2O2, which is hydrogen peroxide, into water and oxygen. That's about it, and it's quite impressive how catalysts can do just that, whereas not included catalysts will actually show us a really slow process. And it's kind of nice because at some point all this kind of activity of catalysts really shows the lifetime and how strong they can last compared to other catalysts which pretty much are active for a specific period of time before they actually go inactive at some point. Thanks for watching, and my next point I'm going to show you on my next video is the selectivity, and I'm going to tell you guys the different selectivities that really shows the strong properties of enzymes. Thanks again for watching. Please don't forget to hit the like button, share and subscribe, and let me hear your thoughts about this particular topic. Did you enjoy it? See ya on my next video. Have a good day. Peace. Love you all. Bye.